Greetings, detectives. This is Mrs. McKay here, and we're ready to work on our 6th learning target clue for Case 8. And what we're going to use today is we're going to use our student assignment lesson pages from Lesson 9.5. So make sure that if you haven't gotten them yet, that you pause this video, that you go get your skinny student assignment book, and you pull out the pages that are Lesson 9.5. Even though we're in Case 8, Case 8 is a combination of chapters 8, 9, and 10 from your book. So that's why the numbers aren't matching correctly. Okay, so now that we're ready to get started, I've went ahead and I've typed across the top our learning target clue, and I'd like you to write it, please. 8.6. I can determine if there is a correlation and a causal relationship in a situation. So the two big ideas that we're going to be talking about today are correlation. Let me get this into the right. Correlation and causal. Okay? A correlation and a causal relationship. Those are the two things that we're going to talk about. So we've already kind of started talking about correlation. And correlation is an interesting word because what it means is co-relation. Okay, so when we see that two things together, that's what co means, have a relationship, that's a correlation. And we've looked at that. We've looked at scatter plots. We've seen that scatter plots can have a positive correlation. We've seen that they can have a negative correlation. Sometimes we didn't really look at any, but if you took any quizzes, you would have seen some scatter plots that don't have any correlation, meaning they're all over the place. They're not showing any kind of trend. So a correlation is when two variables have a relationship and we can see it, okay? A causal relationship is when one variable causes the other. Okay, and that in real world, that's the reason why that happened. So we're going to talk a little bit about that because a lot of times people use statistics to say things that aren't really true. They find a correlation between things where there seems to be a relationship where it looks like when one thing happens, something else happens, but then they immediately jump to the conclusion that because there's a correlation, there also must be a causation, meaning that whatever was happening, one thing is causing the other. So let's talk a little bit about that. Let's look at my first example. A teacher claims that students who study will receive good grades. Do you think that studying is a necessary condition for a student to receive good grades? What do you think? Well, although it's certainly very helpful, it doesn't mean that you have to study to receive good grades. There are students, not a lot of them, but there are some who receive good grades even without studying. Okay? So it doesn't have to be a necessary condition. And then, so we'll say no. Okay? And you can write, it may be possible. To get good grades without studying. May not be likely, but it's certainly possible. Okay, so do you think that studying is a sufficient condition for a student to receive good grades? Well, what does that mean? What does that mean? Do you think that studying is a sufficient condition for a student to receive good grades? That means that if I study, does that mean that that's all that I need to do to get good grades, that that's the only condition, that it's sufficient, that it's good enough? If I'm studying, then I'm going to get good grades. Well, what do you think about that? Well, that's another no, because there are lots of times that students who study, and they study really hard, they still may not receive good grades. So not every student It certainly helps, but not every student who studies is going to get good grades. Now, do you think that there is a correlation between students who study and students who receive good grades? Meaning, do you think there's a relationship? Do you think there's a pattern? Is there a trend that when a student studies, that it's more likely that they'll receive good grades? Yes, there's definitely a correlation. Often, students who study have a higher chance okay? And then the next question, do you think that that it is true that studying will cause a student to receive good grades? Meaning, if I study, then for sure it's going to cause me to get good grades. What do you think? Well, while the students who study have a higher chance of getting good grades, it doesn't actually cause them to get good grades, does it? So, no. Studying helps, but it doesn't cause it. Now this next question says, list 2 or more confounding variables that could have an effect on this claim. When we talk about a confounding variable, it means there might be other reasons or other variables that would affect the decision, that could possibly cause a student to get good grades or cause a student not to get good grades, regardless of whether they study or not. So can you think of other reasons why a student might get good grades even if they don't study? Or even if they do study, why they might not get good grades? What do you think? So I put down a few answers. I went ahead and paused it so that I wasn't wasting time writing. A student who does all of their homework might get good grades. That's different than studying. Studying is like looking and trying to memorize a bunch of information, right? Or reading through notes. But maybe the student does all their homework, and that helps them to get good grades just because of the way the teacher grades. Maybe the student has a high IQ, so they pick things up really quickly and they don't really need to study because once they see it, they remember it. Maybe this person pays attention in class and they're really good at hearing and understanding. So there are lots of different reasons why a student might receive good grades, and we can't say that studying causes it. We certainly can say that it helps, but we can't say that it causes. Let's do question number 2. It has been said that watching TV causes brain damage. Do you think that watching TV is a necessary condition for a person to become brain damaged? That means if a person is going to have brain damage, does that then mean that they must have been watching TV? What do you think? No. No, because a person can have brain damage for other reasons. There's lots of other reasons, right? Do you think that watching TV is a sufficient condition for a person to become brain damaged? Now, a sufficient condition means that if you watch TV, will that then lead to brain damage? What do you think? No, of course not. There are lots of people who watch TV that have never gotten brain damage, right? So it's not a condition. Not every person who watches TV has brain damage. I'm not going to write all that down. And then the next question. Do you think that there is a correlation between watching TV and becoming brain damaged? What do you think? Do you think that that's a common thing, that people who watch TV get brain damaged? No, there's no correlation between that. None at all. People who watch TV are not at a higher risk of becoming brain damaged than people who do not watch TV. It has nothing to do with brain damage. Watching TV and brain damage are not connected. There is no correlation. Okay? Let's go ahead and turn the paper over. So do you think, this is letter D on the back side, do you think that it is true that watching TV will cause a person to become brain damaged? Well, we can say absolutely not, because there's not a correlation. If we've already decided that there isn't a correlation, then there's no way that one can cause the other. And then what are some 2 or more common responses that may also cause the result of brain damage? So can you come up with other reasons why a person might have brain damage? So I've written a few things down. Someone could get in a car accident and it could cause severe brain damage. A baby who is born prematurely might not have their brain fully developed. If a person is lacking oxygen for a period of time, say from a drowning, but they survive the drowning, but their brain goes without oxygen, that can cause severe brain damage. A stroke could cause brain damage. Lots of reasons why somebody could have brain damage, and none of them are because of watching TV. Let's go on to question 3. Question 3 says, for each of the following situations, decide whether the correlation implies causation and list reasons why or why not. So, take a look at this first one. The number of violent video games sold in the U.S. is highly correlated to crime rates in real life. What do you think? Do violent video games cause crime rates to increase? Yes or no? That's no. No correlation. Let me change colors. No correlation, or no causation. There may be correlation. You may see that as the amount of video games is going up, the crime rate is going up, but one is not causing the other. Okay? We can't say that. Let's look at the next one. The number of newspapers sold in a city is highly correlated to the number of runs scored by the city's professional team. The number of newspapers sold in a city is highly correlated to the number of runs scored by the city's professional baseball team. What do you think? That is also no causation. We don't know for sure that the reason that the newspaper sales have increased is because of the runs. It could be that people are very interested in the baseball game and that they're wanting to read about it. But we don't know that. There could be other things that were happening. There could have been a major tragedy. We just don't know what the reasons are why people are buying those newspapers. Let's look at the next one. The number of mouse traps found in a person's house is highly correlated to the number of mice found in their house. So that is saying that if a person has a lot of mouse traps in their house, they have a lot of mice. Or that, do you think that there's a causation there? What do you think? Do you think that there's a causation, that one causes the other? Yes, there's a causation here. Because think about it. If a person has mouse traps in their house, why do they have mouse traps in their house? The only reason is because they have mice in their house and they're trying to catch the mice. So the mice are causing the mouse traps. So there is definitely causation here. And that's pretty much all that we have for this lesson on causation versus correlation. The key is that you ask those questions, that you think about. Is this really causing it, or could there be something else? There's lots of times when people will say, oh, because there's a high correlation, there must be causation or a causal relationship. But that is not always the case. There could be other reasons, or there could be a separate reason that's influencing both of the two variables. All right, make sure that you write yourself a key idea here, just to remember. And you might want to say that for there to be causation, there must be a correlation. But just because there's a correlation doesn't mean that there's a causation. Does that make sense? I hope so. If not, rewind it and listen to it again. I'll see you in class.